In this video, I'm going over the third and fourth question from the performance final exam review. So it's for Mock 10 and Mock 11. So here in the first part of this question, we're just having to solve these equations for x. So here, for example, right, I've got my log, it's by itself, and can't cancel it out, right? So I need to convert it to an exponential. Here my base is 3, so 3 to the fifth power, and that is equal to 8x plus 2. So now we can go ahead and start solving. Well, 3 to the fifth power is 243, which is equal to 8x plus 2, and start solving your two-step. So we subtract 2, so you've got 241 is equal to 8x, and divide by 8. So x is equal to 241 over 8. Now here, b, you have to get the exponential by itself first. We do need to subtract 4 from both sides. Now I've got 125 is equal to 25 to the 2x minus 4. Now we could, first option, see if we can get to the same base, or I'm just going to go ahead and convert to a log since I have my exponential here. So this is log, then base 25 of 125, which is equal to 2x minus 4. So now notice we have change of base here, right? Where we've got log of 125 divided by log of 25, which gives you 3. And that is equal to 2x minus 4. Now you can just go through and solve your two-step where we add 4 to both sides. So 7 is equal to 2x, and then divide both sides by 2, and you get 7 over 2. So now in 1c, again, you have to get this natural log here by itself. So subtract 12 now from both sides. Here I've got negative 3, right? Bring that sign, times the natural log of x minus 12, which is equal to negative 6. Now we can divide by, but in this case, negative 3, because that's what's being multiplied to the natural log here. So now I've got the natural log of x minus 12, which is now equal to 2. Now we can take the inverse of ln, natural log, which is our function e here. So now I've got x minus 12, which is equal to approximately 7.39. So now when I add 12 here to both sides, you do get that x is approximately 19.39. So now our last equation here, 1D, we do have multiple log properties that we need to use here. So like, for example, I see here that we are subtracting, and subtracting means division. So I've got log base 4 of, we are dividing 3 by 4x minus 7. And that is equal to, now notice we do have this coefficient, which can be written as an exponent. That's our other log property here. So log base 4 of 5 to the third power. So now notice in this problem, you have the two logs that are set equal to each other. So now they just cancel out. And I've got 3 over 4x minus 7, which is equal to, well, that's just 5 to the third power, which is 125. Now we can go through here and solve for x. Now, we're dividing by 4x minus 7. So let's just go ahead and multiply, right? Both sides by 4x minus 7 here. So now this cancels out and you're just left with 3, which is equal to, now distribute, right? Multiply the 125 to both the 4x and negative 7. So here you should get 500x minus 875. Now you're just solving a two-step where I'm going to always add or subtract first, right? So add 875, and you have here 878. Then that is equal to 500x. So now all we have to do here is divide by 500. And you are left with 878 over 500. Now, this could also be simplified. So this could be also written as 439 over 250 as well. So you can simplify that fraction as well. And so now in part 2, we are using this situation to answer all 3 parts, where Sally's making a deposit of $2,000. So this is my principal, and making no further deposits or withdrawals for 5 years. So 5 is our T. Now, how much money will be in the account with an interest rate of 3.5% or 0.035 per year, compounded how often? Daily. So that means we have n, which is 365. So we need to use our formula where, because of the compounding, a is equal to p times 1 plus our rate, now divided by n, then raised not only to the t power, but t times that n value as well. So here we've got a is equal to 2,000 times 1 plus 0.035 our rate divided by 365 our n, then divide that by our time in years, which is 5, times 365. Then putting all that in the calculator, you get approximately the amount that's going to be in the count, which is $2,382.47. So then the next part is here we're figuring out savings account with a different, if the bank offers a different rate, so 0.0105, but now compounded how often? Continuously. So now we have P function that we're going to be using in our formula. So that's our PERT, or A is equal to P times E being raised to the rate times time power. So here now we've got A is equal to 2,000 times E being raised to our exponent of 0.0105 times 5 power. Then putting that in the calculator, the approximate amount is $2,107.81. So which bank is the better option? The first one, where you are compounding daily. Well, why is that the better option? Well, because, here you ended up with more money, but you also need to make sure that in this case, compounded daily was still the better option than even the compounding continuously. There was also the difference in the rates, which also makes a difference as well here, because you started off with the same amount of money, you have the same amount of time. Just notice that in the end, compounding continuously could also give you a better option, but in this case, the compounded daily ended up with so $200 more, $280 more. So again, just keeping in mind, making sure to identify which option and that why, that because. And so now here in part 3, we're focusing on expanding our expression given to us, but then we'll need to make sure to explain the process. So here I've got my log, just rewriting the problem here. Now, before you start expanding, we need to make sure to simplify what's inside of the parentheses. So here we still have our log, but I've got 2 over 8. Well, 2 over 8 is 1/4. So 1/4, or I could also have 4 here, because that 1 is going to end up being our coefficient. Then nothing we can do about x. Notice how it's in the denominator, so it stays. Then we have y here. Well, 6y's over 1y. Now you have 5y, so y to the 5th. Then closing. Now, after simplifying what's inside using our rules, now we can go ahead and start expanding. So here I've got log y to the 5th, which is positive because it's in our numerator. Then minus log 4 because it's in the denominator. It's what's being divided. Then minus log x because, again, it's what's being divided here. So here in the denominator. But are we done? No, because whatever you have an exponent, it also needs to be written down as a coefficient. So I've got 5 log y minus log 4 minus log x. So now here, if you wanted to do your explanation, right? Well, what did we do first? We had to first simplify using exponent rules, right? So again, and explain even more. So keeping in mind, right, you had to simplify your values here, the fraction of 1/4, and you had to simplify like terms, like you had 6y over 1y, which is now y to the 5th or 5y's. Then we could start expanding, but make sure to explain, when did you use a positive? Well, when it was in the numerator, right? Then when did you subtract? Well, when it was in the denominator, right? Or when the value was being divided. So again, don't just say now you put your plus and your minus. Why was the log y to the 5th positive? Because it was in the numerator. Why was the log 4 and log x minus being subtracted? Because they're in the denominator, they're being divided. So keep in mind the plus and the because, the y, the minus, but why. Then notice you did not stop there, because we had to then use our log property of exponent, where the exponent then becomes the coefficient. So again, keep in mind, you are still having to explain that last step here, where that 5 now became that coefficient. So now for the Mach 11 question, here we have multiple pieces in our math modeling first section. So here focusing on the sum of our geometric sequence, where remember, right, we need n, we need a, and we need r. N is always the number of terms we're adding up, which in this case is the first 8 terms. Then a, remember, is always the first number in the sequence. Well, the first number is 4. Then R, the ratio, is always what you keep multiplying by, which is 3. We keep multiplying by 3, so R is 3. Then setting up using our formula, where you have 4, so A times 1 minus R to the n divided by 1 minus R. So 4 times 1 minus 3 to the 8th power. Then divide that by 1 minus 3. So when you calculate, you'll get the sum of 13,120. So then here are N, A, and R. N is 10 because you're finding the sum of the first 10 numbers. Now, A, the first term is 8. However, we don't know what R is just yet, but we do know that 8 is the first term. We're missing the second term, but we know the third term is 32. So what do we keep multiplying by to extend this pattern? Well, we keep multiplying by 2, because 8 times 2 is 16, and then 16 times 2 is 32. So we keep multiplying by 2. That is our R. So again, setting up our formula, 8, the first number, times 1 minus 2 being raised to the 10th power. Then again, 1 minus 2. Putting that in the calculator, you get 8,184. So now 1C and 1D have to do with our piecewise and step. Piecewise is the calculation. 1D is actually going to be writing the function. So now here you have to keep in mind when evaluating the piecewise that this value has to go with which of the intervals, which domain values does 4 belong in. Because remember, right, this is f of x. Or actually, sorry, I just realized a typo. It should say h of x. So we'll just say that this is f here. So f of x or f of 4. Well, is 4 less than -8? No. Is 4 between -8 and 5? Yes. So what is the value of f of 4? -1. And that's it. So remember, right, this means that the point for -1 is on the graph. So then here, f of 7. Is 7 less than or equal to -8? Nope. Is it between -8 and 5? No. But is 7 greater than 5? Yes. So f of 7 is, we're going to use x squared, or 7 squared, which is 49. So that means here the point 7, 49 is on the graph. So then the last piece, -10. So is negative 10 less than or equal to negative 8? Yes. So this is 2 times x, or 2 times negative 10 plus 4, which is equal to negative 16, which means that the point negative 10, negative 16 is on the graph. So again, it's taking that x and finding the y value, the output. So now here in 1D, we're going to write the step function. So remember, keep in mind, there are two parts to our function that we need to have. We need to have the step, the y values. So let's go ahead and identify our y values where each of the steps are. So this step here, this line, is at negative 3. Then here, the next line is at 1. Then the third step here is at the y value of 4. But now it's not just y is equal to 4, right? Because notice how it's cut off. So now we need the intervals. We need the domain for each of those steps. So negative 3, well, notice it starts at what x value? Negative 5. So it's starting at negative 5 and stopping here at negative 2. Now notice the symbols. Well, this is closed in, so I need equal, less than or equal to. This is open, so I just need less than. So that's showing that x is between these two values for our first interval, that domain. So then the next step, right, at the y value of 1. The domain or interval for this step is starting at the x value of negative 2 and stopping at 3. Now notice how both are closed in, so less than or equal to, because they're both closed in and we're including those values. Now number 4, or the value of 4. So here at the y value of 4, we're starting here at the x value of 3 and ending here at the y value of 5. So now notice here we have strictly less than because we're not including, right? It's an open and close, so we are including, so less than or equal to. And so now here in part 2, we need to first get the constraints and then identify combinations. Based on this situation of creating these frame packs here, backpacks, we're going to let X be internal and Y be external. Now it takes 4 hours to make an internal. An internal was X. And it takes 8 hours to make an external, which is Y. So that's why you have 4X plus 8Y. And keep reading. The manufacturer has no more than 40 hours per week. So less than or equal to 40. So no more than. And wants at least 4 internal. Internal again was X. So X, because it's at least, greater than or equal to 4. So these are the constraints here that needs to be written. Now, if we wanted to also identify the possible combinations, well, think about it. If I need to make at least 4, then that's 4, yes, 5, 6, 7, 8. So here we are including all of these. But notice the cutoff, right? So I'm not going to go here because this graph shows my situation here of 4x plus 8y, which has to be no more than that, which is less than. So notice that overlap is occurring here in this triangle. So that's where we have our solutions, those possible combinations. So we are focusing on this triangle here. So you're listing 3 possible. So again, there could be all different solutions to this. So I could have, 5, 1, because 5, 1 is here. 6, 1. I could have 6, 2. You could have listed 7, 1. You could have listed 8, 1. Now, could you have listed 8, 2? Well, always then go back and maybe check, right? If I want to list 8, 2, this is my x and this is my y, right? So here in the first equation, 4 times 8 plus 8 times 2. Well, that is 32 plus 16, which is 48. So is A2 a solution? No, because it's greater than 40. So notice how A2 is out of that range. So A2 should not be listed. But again, there are many others. You could even use 10, 0. That is part of that region. So you could have 10, 0, 4, 0. So here, there are plenty of 5, 2, 4, 2. These are all different solutions. And one of the reasons I just told you, actually, a couple of them were one, because remember, right, you have to explain that not only are they in the solution region for both constraints, they're in the solution region for both constraints, but they also follow and make sure if you were to plug in or substitute into either, they make both constraints true. So if they are both of the constraints are true, just like how I showed A2, right? I showed A2 was false because it made 48, which is not less than 40. So again, there's the different explanations here. When you identify your three, that they follow the solution region with both constraints. And when calculating, it makes both constraints true. Now, part 3, we're continuing using part 2. But now the internal frame packs, so that was X, is $30 each. And the external backpacks, they are $45 each, which was the Y. So what is the maximum and minimum profit? So what you have to keep in mind is we want to know from this solution region, what is the max amount? What is the minimum amount? That is when we have our vertices. So 10, 0, 4, 0, and 4, 3. So we have 4, 3, 4, 0, and 10, 0. These are the points that we are going to use, our vertices. And then use this as my X, as my Y, right? And use these values to identify the amount of profit. So like, for example, if this is 4 is my X, then I have 4 times, well, what value is for X? The $30, which, and then there's just 0, so it's just 4 times 30, which is equal to $120. So this point, this vertice represents a profit of $120 because that's for 4 of the small, or for the internal. So then the next one is 10. So 10 times 30, because again, 10 is the X. So 10 times 30 is $300. So now the last is my X is 4 again, so 4 times 30. But now we have to add to that because now we do have a value for Y, which is 3. So 3 times now 45, which this is equal to $255. So what is the maximum profit? $300. So the maximum profit is $300. The minimum profit is $120. So now that we've gotten that mixed maximum and minimum profit, we need to explain the reasoning. So again, how did we get this? Well, we used these 3 points, but don't just say we used the 3 points. What are these 3 points that we used called? The vertices. So notice how we had to take the vertices of the solution region. So we had to take the vertices, right, of the solution region because those are the furthest out to figure out maximum and minimum. Then we use the values to substitute and solve. So notice how here we're still having to connect my X and our Y value. So again, notice how here it's all about identifying the vertices, identifying the X value and Y value, and then going through and solving. We're identifying, we're plugging in, we're solving to see what is the maximum value, the highest value, and what was the minimum value, the lowest value. So again, to be able to identify that maximum and minimum value, the highest and the lowest. So again, make sure that you're identifying all of those pieces when you're explaining your reasoning.